Okay, I'm going to continue on now with the pod discussion. It's going to show how the pods help disassemble the Baer A, B, C, D, and E cells. I just remembered I have to pull another file up. Okay, sorry. So we have to do a little overview of the rhombic dodecahedron and how we have created these depressions in the surface, and that's exactly 1/2 of a pod, because the other half, the same amount that dips into each face, is going to project outward. So I could place a pod on the surface of each one of these 12 depressions, and I would get, it's actually a 24 trapezoidal shape. But anyway, you got to look at that one in a different video. Okay, let's get over to the Baer cells now. So if you recall, I made this form, whatever you want to call it. There's 5 different Baer cells here. This one's A. It's the acute around a point of the fatter rhomb. And then there's the B, which is the more obtuse, has the obtuse angle. The obtuse angle of the rhomb is around that center point. Then we have the C cell right here. And I have to ask for some forgiveness here. I have a big problem with C and D cells, mixing them up when I name them, and I know I've said that in other videos where I've said D when I meant C and vice versa. They have a certain similarity, not exactly though. Here's a D. D actually has 4 of the thin rhombus, and that's the only one like that. They either have 2 at the most or none. And then this last one, the E, is super thin, and it's the most difficult one. It's actually probably why I have avoided making this video, because I'm not exactly done with E, or D for that matter. Okay, let's just say some quick things about the volume. This A, we're just going to use a relative number. If we said that this A cell had the volume of square root of 5, or 2.236068, then we could say that the B cell has a volume of 2. And then we can also say, well, I know these volumes, but then the C cell has a volume of 5, 1.618034, close enough. And then the D cell has a volume of 1. And moving forward, the volume of the E cell is 0.618034, or 5 to the negative 1. So that's a pretty nice relationship between the two of them, or I mean all 3 of them. You can add the D and the E, and that'll give you the square root of 5, so it's the volume, it's the same as the volume as this B cell. And 2 of the D cells, which are 1, would equal the volume of a B cell. So there are some interesting combinations, and well, let's just get forward with why we're here. This is the A cell, and it's pretty plain. When I first thought about dissecting this, I didn't have any clue. I didn't know if I was ever going to bother. But then with the advent of the pod coming onto the scene, and I'm taking off the surfaces here, I've scooped out the equivalent of half a pod. Okay. Now you see how there's a thin wall here between the two? That's kind of neat. It's almost like a membrane for the pods, some sort of fascia between the pods. Okay, so it nicely scoops up on all 6 sides. So what's left? Well, first we'll remove those thin walls that just define where one pod is versus another. Okay. I see that I'm missing a line, and I like to correct my work as I go, I guess. Okay. Now, what do we have here? we have exactly six U modules, or tetrahedra, 6U tetrahedra. So 6 pods plus 6U tetrahedra. That's a pretty nice dissection, I would say. All right, moving on. Here's our B cell. And we're going to dissect the pods out of here, or remove the half pods. This is how I discovered it. It was a very, I missed something there. It was a very, what's a good word? Surprising discovery to find that you could scoop these volumes out, which was the same, in each case, and you'd have this remaining stuff. And I don't know why I bothered to put that back in, but it just has a nice kind of twirl to it. It kind of has a rotational, torquey kind of quality to it. Okay, now you may or may not notice that I just filled in a V tetrahedron here. I was discussing this a bit with the rhombic dodecahedron because 4 B cells actually make a rhombic dodecahedron. So we're going to see like a more up close part of that. So now we're going to remove what is going to be 6 of these. We're going to take their wall panels out, let's say. Oh, first we're going to take out those panels. Yeah, that's the way it should be done. See, I had missed filling this part in. That's why it kind of looked funny, but yeah, I don't know what happened. I think I didn't do the best order, but anyway, what we're talking about here is we have these V tetrahedra on top and bottom, 3 of them, one on this, it's like its outer edge, part of the rhombic dodecahedron edge, let's say. And then there's these 3 here too. So, one of these is the center of a rhombic dodecahedra. It's symmetrical on each end. Okay, so let's remove the rest of that. And then we have this very nice cluster of 6 V tetrahedra. Nice little top to spin. And if you recall, the A cell had 6U, and this one has the 6V. Okay, moving along. This is the C cell. This is kind of, let's say it's kind of like the A cell, and it's kind of orientation of the acute angles around the point. All right, well, this one does have a different face, so we can't scoop that face out. So let's see what happens when we scoop them out. Okay, now we have depressions nonetheless. Well, I guess I illustrated that depression on purpose. This space here is 4 E module forms, and that is kind of a nice way to resolve that depression right away. Resolving your depression. Okay, so there's the 4 E modules in there. Then we can notice that we have yet another V tetrahedron here. And flipped around, we have one on this side. Oh, somehow I let that line get into the mix. That's okay, we don't really care. All right. That is so we see once again we've fully resolved the volume of this form with the half pod, and then filling in the remainder with some stuff of E modules or something like that. Okay, then not lastly, but then the D cell. Now these get a little more tricky now. So you can just see how flat this is, that there's not a lot of room. We're going to take out, first I'm going to add back some lines, and then I'm going to start scooping it out. Okay, there it's scooped out. Now, there's a volume in there that actually requires its own video because it can be shown, but it's just kind of complex. But let's just say that there is a cluster, albeit smaller, fairly smaller, like 2 scales down, of 6W tetrahedron, which I used to call the remainder tet. So, and it's in there. So, of the 5 Baer cells, A, B, and D have clusters of 6, U, V, or W, respectively. Okay, now we're going to spend a little time on this last one, but I don't like these videos getting any longer than this. Here we go. This is your E cell, and it's just too thin. On its own, it's just too thin to put the half of a pod. It just sticks right through. This would be where the pod is, and it goes up above and below. So it pierces through the volume. I have worked on this one, and I know it to a certain extent. It's not fully resolved, but there, I wanted to show you, there's the pod, there's the original pod, and how it bloats out, let's say. God, my words are getting bad. The E cell. So, I don't need to finish this, do I? Alright, to finish up then, this is the pod itself. You see how it's piercing through the E cell. And so it doesn't work very well, does it? Because there would be a pod here, sticking up here. You know, so then they knife into each other, and it's just kind of ugly. Whereas the other 4 Baer cells, they were able to have pods removed off their fat rhombic faces. Boy, that sounds like an insult. Fat rhombic face. But anyway, there you go. Alright, thanks.